Hello friends, welcome to G-Centric. So in this lecture, we will continue with our two-port network, that is ABCD parameters. Okay, so till now we have completed Z parameter and admittance parameter. So this is nothing but ABCD parameter, or other name for this that we can call is transmission line parameter. Okay, so this is called as transmission line parameter. That is because we have seen in the introduction lecture itself that it is used in the power system. So transmission line is used in power system. That is why we will call it as also transmission line parameter. So now to understand this one, okay, so how do we get current at our home or electricity at our home? We will be having some source. Okay, we will write here source or generation. Okay, there will be some generation to reach electricity to our home. Okay, and here we have got our home. Okay, so till here there must be some transmission. Okay, so how do we write this transmission? Using the two-port network is that here there will be some generation voltage which we will call it as V1, and there will be some current I1 flowing from this one. Similarly, when it is get transmitted, we will get some voltage at our home. Okay, it may be single phase, two phase, and there will be I2 current. So now in between these two there will be a two-port network. Okay, so which will be designed by the two-port or ABCD parameters. Okay, so we will draw here two-port network. Okay, so first it was called as two-port network. Now we will call it as ABCD parameters. Okay, so now this two-port is replaced by ABCD parameters. Okay, this is A, B, C, D, and here we have got transmission line, and here the voltage that appears is V1, and here the current is I1. Okay, and over here there is a twist over this side where we have got voltage as V2. Okay, and this is current I2 if we see in this direction. But till now in our whatever we have studied in Z parameter and admittance parameter, we have taken the direction of the current this side. But this is what happens in the actual power system transmission. Okay, so this diagram is valid only for the power system. So when we will study power system, we will use this direction of the current. For now, we will use our two-port network. Okay, so we will remove this one, and we will keep here as I2. So now how you can form the matrix out of this? Okay, so here what we will take is, okay, so we will take here V1 and I1 parameters. Okay, and here we will write ABCD. This is ABCD, and here it will be V2 and I2. So this side will be, so this side V1 and I1 it will be of the source side, V2 and I2 will be of the receiving end. Now in this thing what we have to do, since our actual power system direction is in this way, but we are taking in this way for the network thing, so we will write it as minus I2. So this is important in this ABCD parameter. Rest everything whatever we write the formulas or the equation will be same. So this is the main point in the ABCD parameter. So now if we have to write the equation for this one, so here what are these V1 and I1? They are dependent variables. Okay, so this is the dependent variables. V2 and I2, they are our independent variables. Okay, independent variables. So now we will write the equation. How do we write the equation for this one? V1 equal to, it is nothing but 8 times V2 minus B times I2. Okay, so here we will get minus. Z and Y parameter we used to get plus. Next, that is I1. So let us write this as equation 1. So I1 is equal to CV2 minus DI2. Okay, so these are the two equations that we have got now. Now after this one, we have to analyze. Okay, so when I2 is 0 and when V2 is 0, what are all the equations that we get? So now I'll rub this one over this side. Okay, so we will analyze what are the equations. Now when we do I2 equal to 0, it means it is open circuited. Okay, so when V2 is 0, the terminals are short circuited. So if I draw here again, okay, so this is A, B, C and D. This is V1, and here is current I1. This is V2 and this direction is I2. Okay, so now this is terminal 2, 2 dash and this is terminal 1, 1 dash. Okay, so now what we have to do, let us take I2 equal to 0. So when we take I2 equal to 0, it will be open circuit. That is, first we will take it as I1. So what parameter we will get here as, but we will get first A parameter. Okay, so A is equal to V1 upon V2. So when it is V1 upon V2, it is nothing but when I2 equal to 0. So when will be I2 equal to 0? When we make the terminal 2, 2 dash open. Right. So after this, now see here V1 upon V2. That is the nothing but voltage gain. So what type of voltage gain it is? It should be actually output upon input, but since we are getting input upon output, we will take it as reverse. Okay, so that will be reverse voltage gain. Similarly, in the second equation, when I2 is equal to 0, we will get C is equal to as I1 upon V2. So this is when I2 equal to 0. So when I2 equal to again 0, 2, 2 dash will be open. So now what name we can call it as? By what name? Now this is I1 upon V2. Okay, so it is reverse of impedance. So it is nothing but reverse transfer, that transfer because it is input upon output, admittance. Okay, so this is when 2, 2 dash is open. So when V2 is equal to 0, next we will take V2 equal to 0. Okay, that means we will take it as, they will get B parameter in terms of minus, okay, V1 upon I2, minus V1 upon I2. Okay, so then it is V2 equal to 0 and our 2, 2 dash terminal is short circuit. So what is the name that we can give this one? It is impedance. So forward transfer impedance. Okay, we will write it as Z. Okay, next from this second equation, what we will get when V2 equal to 0, we will get the D parameter. So D is nothing but equal to, again it is minus I1 upon I2. So when V2 equal to 0, same thing, 2, 2 dash terminal is short circuited. Okay, and this we will call it as, again it is input upon output. So reverse current gain. Reverse current gain. Okay, so this is how much, this is about the ABCD parameters. Now we will see some of the questions based on this. What is the important thing that we have to remember in this is the negative sign, that is because in the power system the current direction will be in this way and in this network it is in the opposite way. So we have to add a minus sign over here. Okay, so now we will see some of the problems that was asked in GATE exams. Okay, so we will come to this question. Before that, okay, we have to see synthesis diagram as well, but synthesis diagram for this is not available. Okay, ABCD parameter is not available because it has got different port parameters. Okay, so because of that it does not have, but we have got the symmetricity and reciprocity. Okay, so for the reciprocity you can write it as AD minus BC equal to 1. So this is reciprocity, and for the symmetricity, okay, so for the symmetricity you can write it as B equal to C. Okay, sorry, it is A equal to D. Okay, so this is for the symmetricity and that is for the reciprocity. Okay, so this is about the only, the synthesis diagram is not available for ABCD parameters. So this reciprocity and symmetricity is important because they will ask it in the GATE examination. Now we will come to this question number 219, which was asked in GATE 2015 in electronics branch. So we have to find the ABCD parameter of this one. Okay, they have given the T-shaped circuit. Okay, so we had seen that for the short trick for the Z parameter. So now what we will do is, from Z parameter we will go to the ABCD parameters. Okay, so first we will write the equation of the ABCD parameter. It says V1 is equal to AV2 minus VI2. Let us take this equation number 1, and we have got I1 equal to CV2 minus DI2. Okay, so this is the equation for the ABCD parameters. Now we know that how do we find Z parameter? Okay, first for the Z11 we will add this part. Okay, so how much it is? 5 plus 2 is 7. 7 plus J4. Okay, 7 plus J4. Next we have to see Z22. It is 7 minus J4. Okay, here is 7 minus J4. And this is nothing but the Z21 equal to Z12. So it is 2 plus J0. Here also it is 2 plus J0. Okay, so this is our the Z parameter. Now what are the equations of the Z parameter? It is nothing but V1 equal to it is not AI1, Z11 I1 plus Z12 I2. Here it is V2 equal to Z21 I1 plus Z22 I2. Okay, so this is equation 3 and 4. From this one we can write it as, what is Z11? We have 7 plus J4 into I1 plus Z12 is, this is Z12, 2 plus J0, nothing but equal to I2. Then V2 we have got Z21 as, this is I1 plus 7 minus 4J I2. Okay, so now we also want V1, V2, I2. So check it in the, this is, let us take equation. This is equation 3 and this is equation number 4. So we will see here, come to second equation first, I1, V2, I2. I1, V2 and I2. So if we rearrange this one, we will directly get our C and D parameters. So we want in terms of I1. Okay, so I1 equal to V2 minus 7 minus 4J divided by 2. Here also it is divided by 2. Okay, is that right? Yes. So now C parameter is nothing but 1 by 2 and D is equal to, so here it is 2, 3. So this will become this way, 3.5 minus 2J. So this is our D parameter. Okay, so now what we can do is, we will put this one over here, I1 parameter. Okay, so we have got this I1 parameter. In this equation we do not want, what do we want in this equation? V1, I1, I2 is there. We want V1, I2 and V2. We do not want this I1 parameter. So what we will do, we will put this in this equation. Okay, so in this equation it is nothing but we have rewritten here. So I1 is replaced by this equation. So we will write it over here. V1 is equal to 7 plus J4 times I1 is V2 divided by 2 minus 3.5 minus 2J. Okay, plus how much we have got here? Over here plus 2 plus J0 times I2. Okay, so now we have got V1, V2 and I2. Okay, so when you rearrange this one, you will get A parameter and B parameter. Okay, so find it out. Okay, this is an homework for you. Please find it out, what is the relation you will get. Okay, so nothing but you have to rearrange this one, solve this one, multiply it, you will get V2 and I2. Okay, so we will move on to our next question. Okay, so we will come to this question number 220, which was asked in GATE 2018 in electronics branch. Okay, so the ABCD matrix for two-port network, they have given this, which we already know. Okay, and they have given this circuit, which is again T shape. Okay, so they have asked us to find the B parameter for the given network is. So they have asked only one parameter, that is B parameter. Okay, so now how to proceed this one? Either there are two ways to proceed. Okay, you can take the equations, convert it to Z parameter, okay, then convert to ABCD parameter, you will get the B1. So in that process, what will happen? First you have to find second equation, then you have to put the second equation in the Z parameters first equation. So then you will get the B parameter. Okay, so now the easiest way is that we know what is equations for the power system, that is for the ABCD, right? So V1 equal to A times V2 minus B times I2. So when we will get B? When V2 is short circuited or V2 equal to 0. Okay, so when we make V2 equal to 0, we will get B is equal to minus V1 upon I2. Okay, so this is the parameter that we have got now, minus V1 upon I2. Okay, so if we find what is V1 and find what is I2, we'll get the direct B parameter. Okay, so now here you see, here is the current I1, here is the current I2. So now we are going to short this one, okay, because we have taken V2 equal to 0. Okay, so when it can be D0, it when 2 dash is short. Okay, so now this is I2, here is I1. So what will be current flowing in this one? It will be I1 plus I2. Okay, so now I can apply KVL in this loop. This is loop 1 and this is loop 2. So for the loop 1, okay, we'll apply KVL for loop 1. Okay, what we'll get? Plus V1 minus 2I1. Okay, so this is 5 and this is in this direction, both are in same direction, so it will be I1 plus I2, which will be equal to 0. Okay, next what we can write in loop 2? Next we will go for the KVL for loop 2. So when we apply KVL for loop 2, it is short circuited, so there is 0 current flowing in that one. We'll get minus 2I2 minus 5, again I1 plus I2 equal to 0. So rearrange this one, we'll get minus 2I2. So we want only I2 and V1. We do not want this V1. So we will eliminate it. So this is minus 5I1 minus 5I2 equal to 0. So if I take this one in this thing, everything minus will be outside. So 5I1 minus plus 7I2 equal to 0. Right? So we have I1 and I2. So we do not want even I1 as well. Okay. So this is how much we will get this one. So to eliminate the process of I1, we will take this as minus 7 by 5 I2. Okay. So we will put this in this equation so that I1 is eliminated. So when you simplify this one again, you will get minus 5I1 minus 5I2 equal to 0. Okay, so this minus and minus, it will be minus 7I1. Okay, so I'll put this one over here. V1 minus and minus will be plus 7 by 5. I2 minus 5I2 equal to 0. Okay, so we want the ratio of this one. V1 equal to minus 7 by 5 I2 plus 5I2. So the LCM is 5 here. 25 minus 7 will be 18, I guess. Yes. Okay, so it is 18 or 17. 25 gets 17 divided by 5. Okay, so this is V1 upon I2. Okay, I think it will be approximately equal to 5 5 is 25. 25 minus 7, 8, 9, 10, 11, 12, 13, 14. How much it will be? 25 minus, is it LCM is 5, 5, 25. Okay, so this will be 5. Then you have to minus 7 in this. Okay, so it will be 15. It will be 8. Okay, so this will be 1. It will be 18. So it will be 18 upon 5. Okay, so when you get this one, you will get this as, so you have already minus in there. So 5 1s are 5 5s are 5 4s are is 25, 3s are 15. So it will get 3.1536. Okay, so this is 3.6. Okay, I think here is some mistake that we have done. So this is not minus 7 here. Okay. So here there is a mistake in this one. Okay, I'll rewrite it again. Okay, so here we have to take, we have forgot to multiply the 7 times of I1, that is minus 7 by 5 I2 minus 5 I2 equal to 0. So V1 minus and 49 5 I2 minus 5 I2 equal to 0. So V1 will be equal to minus 49 by 5 plus 5 I2 equal to, that is there. Then here we will get minus 49 plus 25 I2 divided by 5. Okay, so 49, 25, 9, 5, 4, then 2 minus 24 by 5. Okay, this is times I2. So when I take I2 over here, you will get it as minus 5 4s are 28. Okay, it is 4.8 ohms. Now, when you take the B parameter, you should not consider the minus sign because already we have got the minus sign over here. Okay, so it will be 4.8. So you have to enter it as 4.8 in your exam. Okay, in window. Alright, so this is that was asked in GATE 2018 electronics branch. So we will see one more question based on this and we will end this one. Okay, so coming to this question 221 which was asked in electronics branch 2006. So it's a very interesting question. Okay, most of the students skip this one because of the so much of information given in this one, but it is the easiest problem that you can expect. So now they have given the ABCD matrix for two port network. Okay, and if port 2, okay, that is 2 dash terminal is terminated by RL, the input impedance seen at port 1 is. Okay, so they have given 4 options. So now if we draw the circuit according to the question, okay, so this is nothing but ABCD parameters, and here we have got V1, this is I1, and this is V2, here is I2. So what it says, it is terminated by a resistor RL. Okay, so here is the resistor terminated at port 2 dash. Okay, so this is 2 dash. Now they have asked us the input impedance, that is Z in. So how do you write Z in? Z in is nothing but voltage upon current. So Z in is V1 upon I1. Okay, so now this Z in can be written as, we know the equations for V1 and I1, that is nothing but AV2 minus BI2 divided by CV2 minus DI2. So we have got A, B, C and D. AB is in the numerator, CD is in the denominator. Okay, so in these options also we have got in terms of ABCD parameters itself. Okay, so here in this one, this cannot be the possible answer. Okay, and this cannot be the possible answer. So we have to find it in A and D. Okay, so how do we find this one now? We do not want, okay, we have to eliminate everything, right? So it is only in terms of ABCD and in terms of RL. Okay, so we want in terms of RL. So now you can see that RL equation can be written as, okay, it is nothing but V by I. Okay, so here it is minus V2 upon I2. Okay, so now I can put this V2 here. Okay, so V2 is nothing but minus I2 times of RL. So we'll get it in terms of only one parameter. Okay, I'll replace this one Z in. V2 is minus I2 times RL minus BI2 divided by C minus I2 RL minus DI2. So now I can take minus minus, everywhere it is minus, and I2 I can take it as common and it will cancel out. So at the last what we will get, ARL plus B divided by CRL, okay, CRL plus D. So this is our input impedance. So which option matches this one? It is this option D. Okay, we have got ARL plus B, CRL plus D. Okay, so this is how you solve this question. It is a very easy question that was asked in GATE 2006. So now for this one, this ABCD parameters, these many problems are enough for this. Okay, so next we will see with the hybrid parameter. Thank you.